Welcome back to Bazai. Today we're breaking down one of the most fundamental topics in system security, authentication mechanisms. Every secure system, API, and cloud platform depends on strong authentication. And in this video, I'll explain the 4 most widely used authentication methods used in modern systems, how they work, when to use them, and what problems they solve. Let's dive in. First up, SSH Key authentication. This is the default mechanism used for secure server access and DevOps workflows. Instead of passwords, we use a public-private key pair. The client keeps the private key. The server stores the corresponding public key. When a connection is initiated, the server challenges the client, and the client proves ownership of the private key by signing the challenge. No password is ever transmitted. This provides strong cryptographic security, protection against brute force attacks, automation-friendly access for CI/CD and infrastructure. SSH keys are the foundation of secure Linux access, Git operations, and cloud VM management. Next, OAuth token authentication, the backbone of modern APIs and identity platforms. The flow works like this. First, the client sends an access token request with a client ID and secret to the authorization server. The authorization server validates the identity and issues an access token. That token is then sent with every API request as a bearer token. The API server extracts the token, validates it, and authorizes the request. This enables stateless authentication, fine-grained access control using scopes, secure delegation between services. OAuth powers Google Sign-In, GitHub Login, mobile apps, microservices, and cloud APIs. Third, SSL certificate authentication, also known as TLS with certificates. This is how secure HTTPS connections are established. When a client connects, the server sends its SSL certificate. The client verifies. The certificate is not expired. It's signed by a trusted certificate authority. The domain name matches. Then a secure session key is negotiated using asymmetric cryptography. After that, all traffic is encrypted symmetrically. In advanced systems, we also use mutual TLS, where both client and server authenticate each other using certificates. This is heavily used in banking systems, service-to-service authentication, and zero-trust architectures. Finally, the most common method, username and password authentication. The client sends credentials over an encrypted HTTPS connection. The server decrypts the request, looks up the user, and verifies the hash password against the database. If valid, authentication succeeds. This method is simple and universal, but also the most vulnerable. That's why modern systems add password hashing and salting, rate limiting and CAPTCHA, multi-factor authentication. Even today, this remains the entry point for most web and enterprise applications.